Welcome to Get Your FRQ On. This question is from 2023. It's question 3, and it is not calculator active. In the question stem, we have a bottle of milk being removed from the refrigerator and put into a pan of warm water. We have a function dm dt, which gives the rate at which the temperature of the milk is increasing as a function of time, and we know that at t equals 0, the temperature of the bottle was 5 degrees Celsius. We're also told that m of t is always less than 40 for all values of t. And in part A of this question, we are asked to sketch the solution curve to dm dt through the point 0,5. The slope field is given to us. We don't have to fill in any of the little segments here. So using the point 0,5, if you follow the slope field, you're going to get an increasing function. It should bend around and eventually look something like this. Not very well drawn on my part, but I did draw it on Google Slides. But it should look something like this. In part B, we are asked to use the tangent to the curve at t equals 0 to approximate the temperature of the milk after 2 minutes. In order to do this, we need to evaluate dm dt at t equals 0 to get a slope. That would be 1/4 of 40 minus 5. Keep in mind that since the temperature of the milk is 5 at t equals 0, we do need to use the temperature of the milk for m, not the value of t. The function uses m, not t. So that's 35/4 would be our slope at at t equals 0. So our linear approximation here would be m of t minus 5 equals 35/4 times t minus 0. And to approximate the value of m of 2, we're just going to plug 2 in for t. m of 2 would be 35/4 times 2 minus 0 plus 5, which is 22.5 degrees Celsius. In part C of this question, we are asked to find d squared m dt squared, the second derivative of m of t, or the derivative of dm dt, and use that to justify whether our answer that we got in part B for m of 2 is an overestimate or an underestimate. So to find d squared m dt squared, we take the derivative of dm dt. Notice that m is already a function of t, so this will include an application of the chain rule. The derivative of dm dt is negative 1/4, and then we need the derivative of m again as a factor. So we have negative 1/4 times 1/4 of 40 minus m, our original dm dt, which is negative 1/16 times 40 minus m. Now, in order to answer this question, there is part in the question stem. If you recall, m of t is always less than 40 for all t, which means 40 minus m is always going to be a positive number. So our expression for d squared m dt squared will always be negative, since the negative 1/16 is always negative and 40 minus m is always positive, so it's always going to be negative times positive. So d squared m dt squared is always negative, which means that our curve is concave down, which means that our estimate that we found in part B will be an overestimate for the actual value of m of 2. In part D, we are asked to use separation of variables to find m of t using the initial condition that m of 0 equals 5. Now, one thing to understand about questions with separation of variables, even if they don't specify that you're supposed to use separation of variables, oftentimes it is the only way to solve the differential equation, and so if you don't use separation of variables, you are ineligible for many, if not all, of the points for that part of the question. So just keep that in mind. Even if it's not explicitly stated, you're almost always should assume that you're going to use separation of variables to solve these differential equations. So we start with dm dt equals 1/4 of 40 minus m. Move things over, dm over 40 minus m is 1/4 dt. If we integrate both sides, The integral of dm over 40 minus m is equal to the integral of 1/4 dt. Finding antiderivatives for both sides, negative natural log of 40 minus m, and that at the moment that is in absolute values, the 40 minus m. And keep in mind that because the 40 minus m is already an implicit defined function of t, we do need to account for the variable, or the negative m, the derivative, which is going to be negative, so that's why the negative sign is outside of the natural log here. And then the antiderivative of 1/4 dt is just t over 4 plus a constant. Now, since we were told in the question stem that m of t is always less than 40, 40 minus m is always going to be a positive number, so we may omit the absolute value signs here. We can drop them. So we have negative natural log of 40 minus m is t over 4 plus c. Continuing, if we move the negative over, we get natural log of 40 minus m equals negative t over 4 plus c. Exponentiating both sides, 40 minus m is equal to e to the c times e to the negative t fourths. Which means that m is equal to 40 minus e to the c times e to the negative t fourths. Now, since we have our initial condition, m of 0 equals 5, we can plug 5 in for m and 0 in for t, and we can solve for e to the c. E to the c turns out to be 35. So our function m of t is 40 minus 35e to the negative t over 4.